Hi, and welcome to Ask the Professor. My name is Valery Markin, and I'm one of the professors in this course. I'm also a professor at the section of railway engineering at TU Delft, and I'm an expert in switches and crossings, transition zones, and wheel and rail profile optimization. Today we are at the laboratory in TU Delft in the Netherlands. Here you see equipment where students are working on the solutions for transition zones, and so they have to design it, test numerically and experimentally, and finally the best solution wins. Well, let's go to the questions. This time there were quite a number of them. So the first question is from Guido, and he is asking about inclination, rail inclination in turnouts. He is working in Buenos Aires metro network, and they experience high wear on the closure rail. And his question is why the switch rails don't have a 1:20 inclination. Well, inclination is indeed used on the normal track in order to better distribute contact forces, contact stresses. And usually the inclination of the rail is equal to inclination or conicity of the wheel. So you know it from the course. In switches and crossings, usually it's not used because of for the sake of simplicity. Of course, it's not the perfect solution, since it introduces discontinuity or disturbances when the rail, when the train is passing crossing. So you can imagine that you have part of the rail with inclination and then without inclination. So it results in the disturbances of the wheel set. So in the previous days there were no inclination. Now in the new generation of switches and crossing in the Netherlands, they introduced again the inclination of the rails in the main direction. In the main direction it probably helps for the reason I just explained. However, in curves on the closure part it would not help much, because when the wheel set is passing curve, it will still have some lateral displacements. And in this case, introduction of cant, like it's used in curves, would have help much better. On the other hand, in switches and crossing, introducing cant is impossible. So that's why it's also not used. What would probably help is adjustment of the railhead on the on the closure rail, so that the wear on the rail would be reduced. Example of such optimization could be found in the academic papers, paper number 10. When you can see procedure for optimization of the wheel profile. Similar procedure could be also applied to the rail profile in order to optimize with the goal of reduction of wear. In this case, if you do so, you must be careful, since the reduction of wear could lead to increase of RCF, rolling contact fatigue problems. The second question is from Anju. He is asking why there is no speed limit for passing turnouts in the main direction. So we stayed with switching and crossing and turnouts. So he is asking, does the highest speed damages the turnout components as they are very vulnerable? Well, as it also was explained during the in the course material, that the speed limits on the switches and crossings are only introduced for the train when they're passing in the divergent direction. And the limits is defined similar to the speed limits for curves, right, based on the comfort of passengers and lateral forces acting on the track. In the main direction, the speed limits is defined by the operational speed on that particular line. So basically, there is no speed limit on the based on the fact that there is a turnout over there. And as long as we have gap in the crossing, high impact forces are acting on the crossing when the wheel is passing the switches and crossing. So the higher speed, the higher the force, right? But it's not the only factor which affects the amount of forces acting on the crossing. The crossing angle is also affect this force. So the smaller the angle, the crossing angle, the lower the forces usually, and that's why on the main line where the train is passing with high speed, the crossings, the switches and crossings have smaller angle. On the other hand, in some cases when we don't have much space, for example near the stations, the switches and crossings with bigger angle must be used, since they require less space. The smaller the angle, the bigger, the longer the switch, the longer the turnout. So, but in some cases, the turnouts with bigger angle just wrongly used, wrongly placed on the track, and that's resulted that this type of turnouts must be very frequently replaced. First repaired and ultimately replaced. Well, the question is, how can we reduce the forces when the train is passing the crossing in the main direction? So one of the ways is to try to optimize the shape of the crossing rail, and you can find the example of that in the academic papers again. Paper number 2, Performance Optimized Geometry of Railway Crossing, Design and Implementation. So this is the one way to reduce forces and prolong the service life of the crossing. The next question is from Sokyu. It's about the Maeklong Railway in Thailand. He sent a picture of this railway when the train is passing or about to pass the track, which is just coming across the market. So the people make space for the train, and when the train passes, they probably will go back to the track and use the track for their purpose. So his question is, how do they maintain that track? So, in my opinion, yeah, probably they do not maintain this track at all. So you see, the train is passing with very low speed, so as long as the velocities are very low, the degradation process caused by the passing train is also have very low speed. On the other hand, the safety, we have safety issues. Yeah, if the track is bad condition, so we can have derailment in the worst case. But again, the operational speed plays important role in this case. So the slower the track moves, the lower requirements for the track condition and the track alignment we can apply. So on the internet you can find videos when the train is passing the track with very bad conditions, so that the track not aligned at all. Still, it is possible to pass the track with very small speed. So the question to your answer, yes, the quality and the condition of the track depends on the operational speed of the vehicle. Well, and the last question is from Antonio, and his question is about rail defects and welding. So the first question was about the catalog of defects on the rail. So he's asking, is there any similar to road document catalog in railways in which we can identify for each rail failure the main cause of its occurrence. So, I think that Guido answered his question partly. He said that there is a UIC code on rail defects and treatment of the rail defects. So thank you, Antonio, that's absolutely right, there is such catalog. And about of the courses of the rail defects, so I must say, well, follow this course and follow module C, where we'll talk about the long-term behavior of the railway track and about maintenance and monitoring techniques. So basically, when you have this knowledge, you can also predict or to detect, to find the causes of certain defects. And usually, why it's important, because usually it's not one course, it's a combination of courses. So it's very difficult to make such a catalog when you say, okay, this is only one reason for that type of the defect. So my advice, just follow this course, this series of the course, and after that you will be able to do it yourself. And well, the similar answer I could give about the welding process. So the question is it possible to make some calculations in order to define where to make weld? Again, it's based on experience of the particular person, and experience and knowledge, I must say. So based on the course knowledge, you can define better and most important, motivate your decision where to put the weld. So that's all for this week. I must say thank you for sending questions, and next time Professor Dolfoot will be answering your questions, and that's it for this time. Bye.